All right, Trig modeling. You should know what all this means. Okay. Now, this is just having K at the end instead of the front. You know that's still your center line, and it's in Y equals K form. You know what B does? It affects the period change. All right, so that's what this stuff's about. We've been using to find our B value. We've been taking 2 pi, the old period for sine or cosine, dividing by the new period that we see, and that gives us the B value. Because we're going to be writing equations in here, and we're also going to be drawing the graphs. And we're going to figure it out from some data that we're given. We've also talked about the period being 2 pi over B. Now, the frequency just means how many times it's happening in a certain period of time. So if it said 30 times in a minute, then it's 1 out of 30. 1/30th is the cycle because it happened 30 times in that unit amount. Okay, so that's, you don't have to worry about what this means. You really need to know about these old things. The other thing is your amplitude. You know, A stands for amplitude. And you take the maximum value, Y value, minus the minimum value, divide by 2, and you can get your K, which is your center line, by doing the max plus the min divided by 2. So let's look at some problems. It says write a sinusoidal function with a maximum at A and a minimum at B. So A is your max, B is your min. What does a sinusoidal function look like? Well, let's get a clue about what we're looking at here just by remembering a sine wave looks like this. The normal period was 2 pi. This was 0, and what's in the middle was pi. And then this was pi over 2, and this was 3 pi over 2. Okay, so the max was here, and the min is here. That makes sense, I hope. So now, what does it make sense for this? Are these actually the beginning and end of the wave? Or where are they? They're really in the middle, all right? So if it's a sine wave, it's going to start at 0, and then it's saying its max is at pi 8. Well, that's not here, right? So it's out here somewhere. Now, this is saying that the min is at 3 pi, and that's not even at the end either if it's this piece of the graph right there. Okay, so let's maybe make a mark, and I'll say this is pi, and then this is, I'm trying to make it even. Well, if that's pi, this would be, well, I'm not making it very even, am I? So let's think about the period before we even split this thing up. How much of this is it from pi to 3 pi? What's 3 pi minus pi? Okay, that's 2 pi. How much of the period is it? Based on that little picture I drew at the top. From the max to the min is only half the period. All right, so the period's got to be 2 pi times 2, which means we need to go out to 4 pi. All right, so I'm going to split this thing up a little bit better. So it's nice to find your period first before you try to plot any points. So I'll just go to the end with 4 pi. I'll cut that in half, 2 pi. Cut that in half, which will be pi, and then I'll be a scale of pi. 1 pi, 2 pi, in between 2 pi and 4 pi will be 3 pi. Now I can plot the max and the min. So the max would be at pi 8, so that means I got to go up to 8. So that would be where my max is, which is point A. And then it said point B is at 3 pi negative 8, so that would be my minimum. Negative 8 is the lowest value, and that would be your point B. And what's going on in between here is part of the sine wave. Okay, if I want to get the rest of it, what would I do? Well, the sine wave normally starts at 0, 0, or its center line, and goes up to its max. And I just changed colors, guys, so you can see how I'm extending this to get the full sine wave. Didn't need color, but, well, there's our picture. And what is our, well, we found our center line. So if I use those little formulas I was talking to you about, if I take 8 plus negative 8 and divide by 2, that gives me my K value. You add the max and the min and divide by 2. That would be 0 divided by 2, which gave me my center line of 0. right? I don't really have to do that. If you can intuitively look and say, well, what's halfway between 8 and -8? It's 0. Okay, you could find your amplitude. You subtract the max and the min, -8. Well, I guess I should supposed to start with my max timer. It would be 8 minus -8 divided by 2, which is 16 divided by 2, and that's 8. And you already can see by what we graphed or what we're thinking about that you probably already knew the amplitude was 8. All right, so those are ways to get them, given 2 points. Now, if we go 8, and then we have a center line, no center line change, so it's just going to be 8 sine. And now we got to figure out our b value. So b was old period 2 pi divided by the new period that we figured out was 4 pi. You reduce that and you get 1/2. So the b value is 1/2, so that goes 1/2 times x or theta or whatever you're choosing. I'm using x. You can put this in parentheses or not. Okay, number 2. Got a max at 2, 1 and a min at 6 pi. Sorry, I said 2. It's 2 pi 1 and 6 pi -3. So let's first figure out what the period is. We know that if it's the max and the min, that's only half of the period. So if we do 6 pi minus 2 pi, that's 4 pi, which means our period is going to be twice that size. So it's going to be 2 times 4 pi, which is 8 pi. All right, so let's go from 0. Wait a minute, is the center line? Let's see where that center line is. All right, so before I need to put 0 there anyway, because that's where I label my x-axis as it is. So let's go out to 8 pi. Half of that, 4 pi. Half of 4 pi, 2 pi. And then its scale is 2 pi, so 2 pi, 4 pi, 6 pi. We can go ahead and plot those points that were given. Looks like we go up to 1 and down to -3. So before I do that, I better think about my max and my min. So if my max is 1 plus my min -3 and I divide by 2, 1 plus -3 divided by 2, so -2 divided by 2, which is -1. That is your k value. Okay. Now if I subtract the max and the min, 1 minus -3 divided by 2, I'll get my amplitude, which is 4 divided by 2, and that's 2. All right, so now I know I do have a center line change. So it's at -1. So I kind of don't like how I wrote my pi's on there. I kind of wish I'd have figured that out a little sooner, just because I have to go down 2 from there. So if we make, oops, I'll go ahead and write on them the way I wrote it, because you probably did it already too. So if that's -1, I'm going to need to extend my line a little bit. I got to go 2 down from there, so I'll be at -3 for the min. Bless you. And if you want to draw your little dashed lines showing your center line and your min, it's up to you. Now we got to go above there 2, so we'll be up at a max of 1. And that your graph has to stay between there. So I'm kind of teaching graphing again at the same time as I'm teaching the modeling. All right, so if this is, we didn't say, it said to write to a sinusoidal graph, right? So if it's sinusoidal, it's going to start at its center line. There's your point 2 pi 1 would be your next one, which was your a value. Then you come back to your center line at 4 pi -1. You go to the minimum, which is 6 pi -3, and back to your center line. Oops, I just wrote the wrong point. 6 pi, maybe 8 pi -1. All right, sketch the sine wave, and then we'll write the equation. So the equation has a center line change. You can put k at the front or the back. We've kind of been used to putting it in the front. If you want me to, I'll do that. I'll do it 2 ways. -1, meaning on this problem, I'll go ahead and put the k in the front. I'll try to put it in the back some other time. We got a positive opening, so our amplitude or a value is +2 times the sine of, and we haven't figured out b yet. We know the period's 8 pi. So b will equal 2 pi divided by 8 pi, which would be 1/4. So I got 1/4 times x. So far so good, I hope. All right, and again, you could have the -1 out here. If you write it out here, guys, you should put this in parentheses, the 1/4 x in parentheses, so that you don't think it's a phase shift or anything. Just make sure you don't think it is one. Number 3. Now we got a word problem. The displacement D in feet of a boat's water line above sea level as it moves over waves can be modeled by this equation. All right, they've already given us the equation, where T is the time in seconds. Graph the height of the boat over a 3-second time interval. Oh, wait a minute. Now, if T is the time in seconds, then if we're going to graph the height of the boat over 3 seconds, how many waves will we have? It takes a second. Okay, T is the time in seconds. So if there's 3 seconds, we're going to actually graph 3 waves, 3 cycles. All right? So let's graph, we'll split this up into thirds, if you will. 1, 2, and then at the end 3. 1 occurrence is going to happen in that 1 second. Now check it out. The period, remember how we find the period of a function given an equation? We take 2 pi divided by the b value, and the b value is 2 pi. So that's where I'm getting 1 second will occur, 1 wave will occur in 1 second. The amplitude, A, is 2, and there is no K, so we know it's going to be 0 for my center line. All right, so let's figure out the graph. We got an amp of 2, we're going up to 2, and I'm not worried about you numbering everything down to -2. And then we have a sine wave, so we know we started our center line. And then we're going to need to do a whole wave within 1 second. So we're going to have to cut the 1 in half, that's 1/2 a second. Then we have to cut that in half to 1/4 of a second. So these are in 1/4 of a seconds. 1/4, 2/4, 3/4. It's going to be a skinny little graph. So if I have a sine wave, I will be starting at 0, 0, going up to 1/4, 2, back to the center line, 0, 1/2, down to 3/4 of a second, -2, and then back to 1. Center line. 1, 0. I'm not labeling all the points this time because it didn't really tell us we needed to, and I'm not expecting you to on these particular graphs. We could, but didn't ask us to. All right, let's cut this interval up. Cut this interval up, and we'll just keep the sketch going. Up. Make another wave. And final third wave. So got 3 cycles graphed. And it says, what is the time when the height of the boat reaches its max for the second time? Where's that? This is the first time. This would be the second time. It says what time? So that would be 1 and what is our scale? It was a quarter, so 1 1/4 seconds. Or 1.25 seconds. So sometimes you can see things in applications. You can find, by extending a graph, you can find where it reaches maxes or mins over different amounts of time. All right, number 4. The height of the water in a bay varies sinusoidally over time. On a certain day off the coast of Maine, a high tide of 10 feet occurred at 5 a.m. and a low tide of 2 feet occurred at 3 p.m. Maybe we better think about that right away and think about the points. Now I'm going to think about hours. It says, write a model of the height and feet of the water as a function of time since midnight. So time 0 is going to be midnight. Now, I know I got to label my x-axis, so say that's 0 for the amount of time. That would, again, be considered midnight. Now, the next says it's high tide, so it's got a max at 10 feet. That would be the y value. And the x value would be how many hours after midnight? So 5 a.m. would be 5:10. All right. Now, low tide occurs at 2 feet, so the minimum is happening 2 feet is the low tide. That would be the Y value. Now, how many hours is it from midnight to 3 p.m.? Yep, from midnight to noon is 12. 3 more hours would be 15. So that's 15 hours that have passed. Now, remember how we did our max to our min was only part of the wave? Okay, so like we're up here and then we're doing that chunk. Okay, so how long is the period? The x-axis label. From here to 5 to 10, 15 is 10, so it's 2 times 10 to get the period. All right, so that's 20. All right, so let's go out to 20. Cut that in half, 10. Cut those in half, so our scale is going to be 5, 10, then 15, in between the 10 and the 20. Okay, now, what is our y-axis wave? We better check out if we have a center line or something going on here. We had a high tide of 10 feet and a low tide of 2 feet. So let's see where things are. Let's add them. Think about what that stands for. Even if you forgot what max and min is, you know you want to take your max and your min y values, add them and subtract them. One of them's one thing, one of them's another. The other, we can do max 10 minus 2 divided by 2. So I just got through saying you want to add your max and min y values and divide by 2, subtract them, and then you can probably tell which one's which if you say you don't remember. You know, but you do have your green sheet. Doesn't it say on there max plus min, max minus min? Is it on that? You want to check your green sheet? It really doesn't, but I bet you can tell. All right, so it's 10 plus 2 is 12. 12 divided by 2 gives you 6. 10 minus 2 is 8. 8 divided by 2 is 4. Okay, so you've got an amplitude of, which one's amplitude, which one's your center line? We may want to go up. The amplitude is, okay, we didn't remember, amplitude is going to be your subtract one. Okay, this is your amp. This is your center line. All right, let me give you another way to think about it. What is the max point? 10. What is the min point? 2. So if you have a graph there on there, can't you tell which one's which now? What's halfway between 10 and 8? That's 8 units distance. Halfway would be 4 units. So if you went 4 above the 2, it would be 6. If you went 4 below the 10, it is 6. So that tells you for sure that's your center line. Okay, if you ever just forget to, all right. So you got your amplitude and your center line. Now let's get our graph done. 10 was 1 point. The minimum point was at 15.2. Now again, that was only half the wave. We said we're doing a sinusoidal wave. So that means we started our center line, we go up to our max, we come back to our center line, go down to our min, back to our center line. Now you can draw in the center line if you wish, but I didn't do it this time. And now I'm just going to write the equation. I'm going to put my center line at the back this time, just because I want you to have done it and so you would recognize it. It's a sinusoidal wave with an amp of 4, so it's 4 sine. We had a period of 20, so we need to take 2 pi divided by 20. And that gives us pi over 10 for our b value. Okay, so that's pi over 10 times x. I'm going to put that in parentheses, and then I would add on my center line at the end, which is your k value. It can be in the front or the back. Now it says use your equation to predict the height of the water at 2 p.m. Okay, now here's what I suggest. You go look at the picture for a minute, and you say, well, wait a minute. This is 5 a.m. That's 10 a.m. 15 was our 3 p.m. And remember, this was good for 15 hours after midnight, okay? 3 p.m. So that means that if I want to know at 2 p.m. what the height is, then it would be back here, right? Follow me? So this curve, now I'm going to make sure you realize that this is actually not drawn perfectly. What should the value be there? A little above 2. Okay, so now let's grab our calculators. We're going to be putting in how many hours is it 2 p.m. If 15 is 3 p.m., then 14. We're going to let x equal 14. All right, I want to teach you something about this or get you guys to figure something out. So I'm going to have you go ahead and just type this in. Our equation was 4 sine. We had pi divided by 10 for our b value. Oops, I hit something wrong. 4 sine pi divided by 10. I want to see what you guys are getting. Are you getting something that makes sense? We're going to put in times 14 for x. And I closed up my parentheses because now I have to add on my center line plus 6. Okay, how many of you are getting 6.36? Is anybody getting anything else? We just said, what should it be? A little above 2. So this isn't right, is it? All right, I'm trying to make a point. You need to look at your graph, know if you're, what can you check now? What would be wrong with our calculators at the moment? The mode that it's in. Okay, why? Our mode is in degrees. Well, we've left it in degrees for everything else. But what's our equation in that we made? It's in radians. If you're going to put a number x, a value of x, into an equation that's in radians, you have to go ahead and change your mode. So if we just go down, hit radian, hit enter. All right, now just hit second quit. If you go back here and just hit enter again, it'll do it over. And bang, there's the answer we were expecting. So it's about 2.2, I think that was in feet, wasn't it? Yeah, feet. 2.2 feet. All right, let's go to the back of 45. Okay, the paddle wheel of the SS Brogan was 13 feet in diameter and revolved 30 times per minute when moving at top speed. It's happening 30 times in a minute. So what's the frequency? 30 times in a minute. So it's 1 out of 30. That means my period is 1 out of 30, 1/30th. One cycle is going to happen. So if that thing's spinning 30 times in a minute, it's going to do 30 waves in 1 minute. Right? So that's why 1/30th would be one cycle. Right. Using this speed and starting from a point at the very top of the wheel, write a model for, I don't know why it says form, for the height in feet of the end of the paddle relative to the water surface as a function of time. All right, well, there's 0. Assume the paddle is 2 feet below the water surface at the lowest point. No, paddle wheel's got to go in the water, else it's not going to move. Make sense? Okay, so some of it's got to go into the water. So where should we put the low value? What's our low y value? 2 feet below 0, not 2 feet above. So it's at -2. Okay, now, it said that the wheel, I'll draw a little picture, had a diameter of 13 feet. Now, here's the water line, right? It's going below there. That's -2. So if that's 13, where are we getting to max out at? 11. Okay. So we'll just stick 11 up here. Okay. All right. So we got a minimum at -2, a max at 11. let's do our little trick to get our center line and our amplitude. So if we take our max 11 minus our negative 2 divided by 2, that gives us 13 divided by 2, which is 6.5 amplitude. That is your amp. The center line is going to be, when you add them, 11 plus negative 2 divided by 2, averaging your max and your min. That gives you 9 divided by 2, which is 4.5. Okay, so just make some random mark, 4.5 here, which is, of course, above 0. I'm not trying to write this to scale. We're just getting a sketch and being able to write an equation. All right, what was our period? Was 1/30th. All right, so, okay, I'll just stick 1/30th way out there. Why not? Half of that, 1/60th. I'm not going to label these other ones. Half of that's 1/120th, and then blah, blah, blah. Okay? Let's get it sketched. So what kind of wave? Wait a minute. Where are we starting, guys? It said, yep, it said that we need to assume that we're starting at its highest point. Where was that? Use this speed, using this speed starting from a point at the top of the wheel. That's up here. Then we're coming to the center line. Then we're going to the min. Then we're back to the center line. Then we're back to the max. Oops. All right, so I'm going to sketch the motion or the height of the paddle wheel over time at one given point on the wheel. It's not a sine, is it? This is a cosine. All right, so let's do our amplitude was 6.5 times the cosine. Now, let's get the B value. What? 4.5 is the center line. Oh, I put those on the wrong poop. Thank you. Oopsie, that was bad. I totally spaced it about my center line. I was all busy getting going here and just ignored it. All right, yes, those have to be up where they on the center line, not on the x-axis. Thank you for stopping that. All right, let's get the B value. All right, so we take 2 pi divided by the cycle of 1/30th, and 2 pi times 30 over 1 gives us 60 pi for the B value. Okay, so we put 60 pi times x. We could close that in the parentheses and then add on the center line, which is 4.5. Okay, yes. Oh, I was running out of room and I squeezed that in there, didn't write the 6. It's a 0. Oh my gosh, I gotta get it together. 60 pi x is, the B is 60 pi. Write it right there, and then I lost my 0. Leave that for a moment? Sure. Guess I can draw my paddle wheel. You're welcome. All right, suppose a Ferris wheel. Oh, we got another wheel. When you're on a Ferris wheel, is your bucket on the ground? No, it's going to be up in the air. We don't want our rear ends hitting the ground as we go around the Ferris wheel. All right, so it says, suppose a Ferris wheel has a radius of 20 feet. Oh, that's only a radius. And operates at a speed of 3 revolutions per minute. I don't know why it says minutes. 3 revolutions. So what is our period? If it's 3 times a minute, 1 cycle will happen in 1/3 of a minute, right? Period is 1/3. Okay, now this is 0. Period's a third. I'm going to go out to here. Cut a third in half. I'll be at a 1/6. Half of that's a 12th. 1/12, 2 12s, 3 12s will be 1/4. Okay, now I'll talk about seconds later. It says the bottom car is 4 feet above the ground. Okay, so let's note that our bottom car, the lowest car, is 4 feet above the ground already. That's like right there, 4. So check this out. If you think about the picture here, maybe that'll help you with the ideas. This is also a radius. So how high above the ground are we in all when we're up here at the top? 44. Ooh, well, let's at least make this go up a little higher than it does. So now I got to figure out my center line somewhere in between there, right? You got your max 44, your min 4. So let's take 44 minus 4 divided by 2. That'd be 40 divided by 2, which is 20. Now remember, when you subtract, that's your amplitude, A. Okay, so if you want to think, here, let's just use common sense about where our center line is. 20 above 4 would be 24. 20 below 44 would be 24. Then we know that that's where our center line, that's 24. Okay, I'm going to dash it out so I don't miss it, not plot on it like I did on the last problem. Okay, it says, let's read the question again so we can make sure. Oh, look at this last part of it. P0 is the height of 44. So it's starting at 0, 44. Now what's our view then? Sine or cosine? That's going to be a cosine graph. Okay, so we'll come to the center line. We'll go to the min. We'll go to the center line, back to the max. Oops, not a very good curve I made there, but all right, so there's our graph. And this is definitely the kind of question you will have on your unit test Friday. We've got our model equation. We're ready to write our equation. We want to start with the center line. That's fine with me. 24. It's got a positive amplitude or A value of 20. It's a cosine wave. Now I got to deal with the period is 1/3. So I'm going to find my B value by taking 2 pi divided by 1/3. That will be 2 pi times 3, which would be 6 pi. That's your B value. So 6 pi times x, no phase shift. Okay? If you can understand this, this kind of tells you forwards and backwards about graphing trigonometric functions, the applications. Okay? We made up a graph based on a word problem. We've now written an equation for it. That's really understanding the material. All right, use your equation to predict the height of the rider at 90 seconds. There's a little problem here. We're in, yep, minutes. Okay, so we can convert 90 seconds to minutes if you want, which would be 1.5. There are 60 seconds in a minute. 1.5 minutes. Then we can plug in 1.5 into our equation. We are all in radians now, right? So we're ready to go. Put in 1.5 into our equation. So I forgot which one this is. This was my Ferris wheel problem. 20. I got cosine. Okay, it doesn't matter if you put the center line at the front or the back. I'm typing it differently than you might be. 6 pi times, we're putting in 1.5 minutes. We could have written an equation in seconds. And then outside of that, I would have to add on my 24. And I got 4. Okay, so 4 feet. I guess that was the easier way to do it, plugging it into the equation we made instead of extending this graph, right? Whew. Since that's only, what's 1/3 of a minute? That represented 20 seconds. We'd have to have gone quite a ways out to get to 90 seconds. This would have been 10 seconds, etc. All right, 7. 2 more. When you strike a tuning fork, the vibrations cause changes in the pressure of the surrounding, what's it say after that? air is what I thought. Okay. All right. A middle A tuning fork vibrates with a frequency of 440 cycles per second. What's our period? 1 cycle would be 1/440th. Okay. How many times it happens? And this is in seconds. You strike a middle tuning fork with a force that produces a maximum pressure of 5 pascals. The 5 pascals, that's going to be your amplitude, maximum pressure. Okay, so that's your amp. So that's going to be our y-axis, 5. And then when everything comes back, what do you think happens with a swing vibration? It's going to go to 0 in the middle and then down to a min of -5. All right, so that is your amplitude. Our cycle is 1/440. I only think I'll cut one of those in half. Let's see. Half of that would be 1/880. And I'm not labeling the rest. I'm just going to put tick marks for the other key points that we need to graph it. Okay, so this says, what if it says write a sine model? So we're going to start at 0, 0. We'll go up to our max, back to our center line, down to our min, back to our center line. So we got the graph. All right, so this is sinusoidal. Our amp was 5, so it's going to be 5 sine. There's no K. We need to get figure out the B value to get that period. So B would equal 2 pi divided by 1/440. We change 2 pi times 440, which would be 880 pi times x. Did I go too fast on that one? Okay. All right, that's it for that one. It's actually easier than some of the other ones. All right, 8. Motion of a certain pendulum can be modeled by, they gave us the equation. Where d is the pendulum's horizontal distance displacement in inches relative to its position of rest. Its position of rest would be its equilibrium position, which is straight down before a pendulum starts swinging. Okay. All right. It says time is in seconds. Graph the function. How far horizontally does the pendulum travel from its original position straight down? How far horizontally does it travel? So we're going to want to know this distance. All right, let's figure this thing out. We've got an amp of 4, so let's go ahead and put, and there's no center line, so that's going to be 0, going up to 4, down to -4. The B value is 8 pi, so the period is the old period, 2 pi, divided by the new period, 8 pi. Oops, I just am doing the backwards thing. I'm just on autopilot, sitting there going, all right, what? No, I was doing that right, wasn't I? Pi divided by B. Okay, 8 pi. What is that? 1/4. Okay, 1/4. All right, so I go out to 1/4. That'll be 1 cycle. Half of that's 1/8. Half of that's 1/16. 3/16 is the third mark. Okay, and it says, are we doing a sine or cosine? This thing was a cosine graph. So you start up high, go to the midline, down to the min, back to the midline, and back to the max. My pen's stuck. Okay, since it completes 1 cycle in 1/4 of a minute, what's the horizontal distance from the original position? Well, let's try it. Plug in 1/4. So 4 times the cosine of 8 pi times 1/4, or 0.25 if you prefer. Everyone calculate that, please. I'm not going to. You're getting 4. Okay, because this thing, that was the whole point of this, is the distance at the pendulum's horizontal displacement. So we got 4, and that's in what? Inches. All right, your assignment is the next worksheet, which is 46 and 44. You might want to start working on some reviewing. Tomorrow, we'll start doing the unit review, so we'll have 2 days of review / questions, and then our test is on Friday. And by the way, I have given in an extra day since we were ahead. They're testing Friday and the other honors algebra 2 classes as well.